Hi everybody. I'm glad to have the opportunity to share our recent work, E2E-LOAD, end-to-end long-form online action detection. This is the outline of our work. I will share our paper according to the four aspects. First, I will give the introduction to our work. Online action detection aims to recognize ongoing actions. When dealing with video streams, we can only access information up to the current moment, and any data from the future is inaccessible. Recently, OAD has emerged as a crucial field in computer vision, owing to its wide range of applications, such as surveillance and autonomous driving. We are facing two main challenges, and let's dive into each of them. 1. When dealing with video stream, it is often essential to consider long-term dependencies, but using a heavy video backbone to model local chunks can underutilize its potential to capture these dependencies. 2. Using optical flow is a crucial technique for enhancing performance, but it also introduces a significant computational burden. So, why are we proposing this framework? Firstly, our goal is to create an end-to-end training framework, which means we can achieving a better balance between accuracy and efficiency. Secondly, we aim to enhance accuracy and speed in practical applications. In the upcoming presentation, we will delve into the workings and key features of this framework. Let me explain the details of our model. We present the architecture of E2E-LOAD, which utilizes a stream buffer to extract and cache spatial representations of incoming frames. These representations are then divided into two segments. The older, longer segment is directed towards a long-term compression branch for temporal resolution compression. In contrast, the newer, shorter segment is sent to a short-term modeling branch to carefully model the recent context. Finally, these two representations are fused via a long short-term fusion module to predict the most recent frame. During inference, we introduce an efficient inference technique to accelerate the spatiotemporal exploration of short-term modeling. We will discuss these aspects in more detail. We introduce a spatial attention module with a buffer to store intermediate per frame features for video stream. This module transforms raw frames into reusable compact and semantically rich representations, reducing the computational load for spatiotemporal modeling. We then apply spatiotemporal modeling among these features in stream buffer. Such a space-then-spacetime design fully uses the backbone's representational capacity for long-range dependencies, avoiding unnecessary computation of dependencies within individual chunks. Over time, the streaming buffer accumulates a substantial number of video frames. We compress the historical long-term sequences into multiple spatiotemporal feature maps, extending the contextual timescale for our short-term modeling module. We investigate different fusion operators, such as cross-attention and self-attention, as well as their positions within the framework to achieve more effective fusion between long-term compression and short-term modeling. We have observed a notable inference time cost during spatiotemporal exploration in short-term modeling. To address this challenge, we introduce an efficient inference technique, which directly reuses results from the previous TS-1 frames, so only the latest frames features require calculation via cross-attention. Next is the experiments part. In our study, we have conducted a comprehensive evaluation of our method by comparing it to existing approaches on three well-known benchmark datasets. The results clearly indicate the superiority of our method in terms of both effectiveness and efficiency. We provide visualization of attention distribution within the short-term modeling, which depicts the correlations among subjects at different time steps. At last, I will make a summary of our work. We propose E2E-LOAD, an end-to-end framework based on Transformer for OAD. Our framework successfully tackles the crucial challenges, including the aspects of long-term understanding and efficient inference. Our contributions can be summarized as follows. 1. We propose a unique end-to-end learning framework that integrates a stream buffer to enhance the effectiveness and efficiency of online data processing. 2. We introduce an efficient inference mechanism that accelerates spatiotemporal attention. 3. Our method achieves significant accuracy and inference speed advancements, highlighting its promise for real-world application. Okay, that's my presentation. Thanks for your attention. If anyone requires more information or has questions, please feel free to contact me.